Now that you've watched the first video that explains some of the big picture ideas, let's try to work some problems. And your review will have the answers at the bottom, but this goes through and tries to find the actual answers and how to get those answers. How do you find the slope of the line that passes through each pair of points? Well, in this case, it's kind of nice to read the problem and realize I don't have to get an equation, I just have to get a slope. And remembering my slope formula lets me plug in, if I label x1, y1, x2, and y2, I get 18 minus 16 over 20 minus 12, and that is 2 over 8, which is 1/4. Slope of 1/4, that is our answer. Now if we go over here and apply the same thing, I'm going to ask you to try it on your own, and so hit pause, try to get the answer, and then see if you got it correct. Okay, let's go ahead and label and get our answer. We have x1, y1, x2, y2. We now have -3 minus 8 over -1 minus -4. That'll be a +4. So we get -11 over 3. There's our answer. So you'll want this formula memorized, and you probably already do have it memorized. Moving on, what's the slope of each of the following lines? Well, this is kind of nice because of the three representations, when you have a line that you know is linear and it's in y equals form, you just pluck off the coefficient. So in this case, m will equal 3. Over here, it's a little bit tricky. You don't want to pick the fraction just because that's the way slopes usually are. Again, you want to find a coefficient of x, and that value is a -2. And now this one, just like the previous benchmark, you had to solve for variables. In this case, we need to solve for y. Do not assume 2 is the slope just because it's the coefficient of x. You must be in y equals form. We get there by subtracting 2x from both sides and then dividing by 7. Y equals a y-intercept of 15 over 7. It doesn't have an x by it, so that's our y-intercept. And then minus 2 over 7x, that's our slope. All right. Write the point slope equation of the line that, we have 3 situations, has a slope and a certain point. And since we just get to use point slope form, all we have to do in this case is plug in, because they've given us an x1 and a y1 and the m. Remember that even in an ordered pair, you're going to get the x first, the x1. When we write our equation, it's the y1 we want to list. So the answer is y minus 100 equals 5 parentheses x minus 10. And we are done. For part B here, we've got 2 points, so we don't know the slope directly, but we do have a way of getting it from that previous problem. If we recall that m equals y2 minus y1 over x2 minus a negative, in this case is plus, x1. So we get a 2 over 4 reduces to 1/2. And now I can choose either one of these points. I'm going to use the one that doesn't have a negative, although it won't matter, and write y minus 6 equals 1/2 x minus 1. You could use either point. Here they're giving us information, again indirectly. We have to be able to find a slope from the equation given and then know how to use that, the information about being parallel. So the coefficient of x is a -4. Parallel lines have identical slopes, so my slope is -4. They've given me a point, and I simply write y minus y1, in this case a -35 is y plus 35, equals my slope, -4 parentheses x minus 5. This point slope form is very useful. Sometimes we want to convert it into intercept form, slope intercept form, but it's nice to have this equation available. And sure enough, we look at question 13, we need each of these. So we'll paste these equations. We need to find the form for slope-intercept. Given these forms. All right. That's kind of annoying. All right. Our method for turning into slope-intercept form is to simply distribute and solve for y. So if we distribute the 5, we get 5x minus 50. And then we have a plus or a minus 100 that we need to undo. We undo by adding 100. Combining those like terms, we get y equals 5x plus 50. And we are done. Likewise, with this equation, we're going to want to distribute first. And then undo minus 6 with plus 6. A little bit of a problem here is that we don't have a common denominator when we're trying to add fractions. We need to assure that we have a common denominator. So this becomes y equals 1/2 x minus a half plus, think of it as 6 over 1. 1 turns into a 2 by multiplying by 2, so we multiply top and bottom by 2, and we get y equals 1/2 x minus 1/2 plus 12 halves, and that is y equals 1/2 x plus 11 halves. All right, and then to finish up here, distribute. Remember, distributing a negative, when you multiply negative times a negative, you get a positive. And to undo plus 35, we subtract 35, leaving y equals negative 4x minus 15. Now for these problems, rather than being given an equation, we're given a graph. And one of the somewhat tricky things about this first one's not too bad because the y-intercept occurs right there on the y-axis. It's given as a 300. And so typically what we need to find then is the rise over run. Now check your units. You have a rise of 50 and a run of just 1 unit if you look down here on the x-axis. So our scale has changed, and the rise over run is just 50 over 1. So I have a slope of 50, a y-intercept of 300, and we can write y equals 50x plus 300. Likewise over here, this is where it gets a little tricky. I don't really have the y-intercept. I have my last point showing up when x is 2. What I need to do is work backwards here. And so if I find the slope is negative 100 over 1, negative 100 over 1, my slope is negative 100, and I can use that to figure out what the y-intercept is. That's not quite the y-intercept. That's a value of y when x is 1. I need to go up and back, so it's 900. That's the value of y when x is 0, 900. And my equation then is y equals negative 100x plus 900. Sometimes kids get a little bit confused on the slope. Remember, this looks like a negative slope. It's definitely decreasing from left to right. And so if you're writing your answer and you look at the answer and go, wait a second, that slope doesn't look like it matches, make sure you check to see that you've got the correct sign. Now if we look here, write the equation of the horizontal line through 1, negative 2. This is one of those unique cases that I'll need you to think about. The point 1, negative 2, pretty easy to graph. Just sits out here. But when we think about a horizontal line, we want to make sure we look at it and think, now what could that be? This horizontal line here has to be an equation in y equals form, because horizontal, remember, is y equals a constant. Well, what does the value of y equal for every single point on this line? Well, it equals -2. And the reason this is a horizontal line but uses the letter y is because y becomes a constant, and when you pin down the y value to never vary, go up or down, your slope is 0, and you have a horizontal line. Now similarly, if you look over here at this vertical line we're going to do, we want to pass through the point 1, -2 again, but now we want it to be a line that goes vertical, up and down. When we look at that, we see that x is pinned down now at 1. So our equation is going to be x equals that x value of 1. So even though it's a vertical line, our equation does have an x equals because it becomes a constant. Now I want you to take a moment and see what you can do with questions C and D. See if you can write the equations for a horizontal line through the point 310, vertical line through the point -150. Hit pause, see how it goes. Okay, based on the previous problem, if you think about this, the horizontal line will be a y equals equation, and it has to pass through the y coordinate of 10. So y equals 10 is our answer. Likewise, this vertical line is going to be an x equals, and it has to pass through the x coordinate, in this case, -100. Now there's not a lot of good math to do here. It's pretty much memorized, and you can think through it a bit, but you're going to want to memorize some of this stuff and just be prepared for it. I suggest you memorize the horizontal line is the y equals, or the vertical line is the x equals, and then you'll know the other one has to be the other option. So get those memorized though. Question 16, sketch the graph. So now we're given an equation. We want to sketch the graph. These, you've probably done a fair amount of these last year and this year. We're going to find our y-intercept, or our value of y when x is 0. Plot that point, and then the slope is the coefficient of the x, -1/1. So we're going to go down 1/1, or sorry, right 1, down 1, right 1. Connect these dots, because again, this is not a scatter plot. And we get an equation, or a graph that looks like this. All right. Likewise, for this equation, we want to find the value of y when x is 0, and that's a 1. So our y-intercept is 1. Slope of -2 means down 2, right 3, or we could go up 2, left 3. When we connect these dots, we get this graph. And finally, value of y when x is 0 is -3. So I plot the point -3, move up 2, right 1, up 2, and right 1. Connect these dots. And there's our graph. And you should think about doing these problems and then coming back when you've had time to forget possibly, and see from the graph, like if you were to block out the answer up here, see what would happen if you could come back and get the right equation that we found earlier. Okay? But for now, that's not the case. All right. That ends our lesson, and I hope that you're able to do well on this benchmark. And remember to come in every day to retake it if you're not passing it, and ask the questions, because these things come up a lot, this linear equation, for the next 2 or 3 years of your math academic career. We'll see you in class.